Hi, I'm Rob O'Mara. This research was part of my Masters of Science dissertation at Birkbeck, titled Observers Dynamically Adapt Perception in a Changing Environment. So people are subject to continuous streams of visual signals which need to be processed quickly and accurately to be of any use. To facilitate this process, the brain leverages prior expectations of what is expected to be seen. Previous research has shown that surprising observations result in worse performance in visual detection. We also know that surprising observations result in an update of what is expected to be observed. The question this research aims to answer is how do observers update their expectations when perception is degraded by surprise? And does perceptual performance evolve over the course of an experiment as participants learn to expect changes? To answer these questions, we've tested people online. Participants were asked to focus on a fixation point, seen here in Figure 1. A peripheral stimulus would appear on a ring around a location drawn from a normal distribution around a given mean. Participants would see between 10 to 20 trials before a new run started. Each new run had a new mean. Participants were asked to monitor for a change in contrast in the peripheral stimulus, seen in Trial 3, Run 1, or for the presence of a fixation ring, seen in Trial 1, Run 2. Change point modelling was used as it gives the probability that the peripheral stimulus is coming from a new distribution based purely on observations. That is, given the current location, what is the probability that the location is drawn from a new underlying distribution? The second figure here recreates previous findings that as change point probability increases, the visual detection ability of participants decreases. To investigate how participants adapted to the changing environment, the calculated change point probability was decayed. This figure here on the left shows that when there is a large jump in peripheral stimulus location, seen by the red dots, there is a spike in change point probability, seen by the black lines underneath it. The blue line here shows one particular decay model that was tested, where the change point probability was capped as the trials increased. Decayed change point probability performed better in modelling hit rate than raw change point probability. This last figure here shows that participants do indeed adapt perception across the experiment. So in this research, we were able to recreate findings that visual detection ability decreases as change point probability increases. Additionally, we're able to show that the effect of these high change point probability observations decreased, as shown by the decayed change point probability outperforming raw change point probability in the modelling. Ultimately, people have worse perception of unexpected observations, but adapt perception to lessen the negative impact in a changing environment. In this study, participants were only required to expect changes in the mean of a normal distribution and showed that they could adapt over time to changes in this. In future studies, I'm interested in exploring the complexity of these prior expectations that can develop, going beyond a simple normal distribution and looking at multimodal and skewed distributions. Additionally, there's a question here around how poor perception necessitates poor learning. Thank you.